Okay, you guys, in this video I want to work on solving rational equations. Now, remember, I'm not simplifying, we're solving rational equations, right? I want to just solve one problem, but if you don't mind, I'd like to show you two of many options that you might want to try. The first option, so let's call this option one. Uh, option one, option one, option one, simplify both sides and then cross multiply. So I'm going to simplify this. So right now all I'm doing is I'm looking at this piece right here. So what I've done now is I'm just going to look at this piece right here. Yeah. And I'm going to simplify this piece. So, right? So I see this piece right here, and I'm going to figure out, okay, what can I do with this? So, and I realize this piece is over here. I'm not going to mess with that just yet. But I'm going to try to simplify this. And so first thing I'm going to do is the least common denominator here. Well, what's the least common denominator? This denominator has a factor of x, and this one has a factor of 2. So this one, to make them the same, this one would need a factor of 2. So I'm going to do 2 over 2. And I know that you've been told before by your teacher, whatever his or her name was, whatever you do to the denominator, do the same thing to the numerator. Look, what they should have told you, what they meant to tell you was multiply by 1. Take any number, take a number, say the number out loud, multiply that number by 1. Got the same number back, didn't you? Take a fraction, multiply that by 1. So 2/5 times 1 is still, okay? So that's all we're doing here. This side, I'm going to multiply this by x over x. But you see what happens? I am multiplying by 1, but look what happens. 2 times 4 is 8, isn't it? 2 times x is 2x. Now, if you want to look at it, this simplifies. 8 over 2 is 4. It's 4 over x, though, isn't it? Okay, so this plus sign right here, if you don't mind, is this plus sign right here. 5 times x is 5x, isn't it? 2 times x is 2x. If you went back and looked at this and to ask yourself, do we still have equivalent fractions? X over x is 1. That cancels out. You go back to 5 halves, wouldn't you? Okay, so equals negative 11 over x. But look, now what we can do is this. We know that 1/3 plus 1/3 is an easy piece of math, isn't it? Do we add the denominators? No, we do not. We make sure they're the same, and then we bring them over, and we add the numerators, don't we? So 1 plus 1 is 2. So you're like, Charlie, why are you telling me this? Because these also have the same denominators. We're not going to add those denominators. We're going to take them and say, okay, the denominator is 2x, isn't it? And then what is 8 plus 5x? Remember, you can't add unlike terms. This is 8 ones. This is 5x's. So 8 plus 5x's is 8 plus 5x's, right? You can only add x's to x's and y's to y's and ones and numbers to numbers, right? So equals negative 11 over x. Now we're going to do this thing where we're going to cross multiply, and I want to show you why cross multiplying is okay. So what I'd like you to do for yourself, if you don't mind, is take a fraction that you believe is equal to itself. That is to say, I believe that 1/2 is equal to 50 100ths. And I'm just going to show you why it's okay to cross multiply, because if we cross multiply, 2 times 50 is 100. Cross multiplying, 1 times 100 is 100, and 100 equals 100. Okay? So why is this okay to do? For this exact reason. All right, so here we go. A little bit more math here. We're almost done with option 2. And it looks, I'm sorry, with option 1. So it looks like this. 2x times negative 11, we're cross multiplying this way, is negative 22x, isn't it? And then we have, look, this x times this mess looks like this. This x times, right, this mess over here, so 8 plus 5x, isn't it? And all I'm going to do is distribute to here and to here. And 8 times x is 8x, isn't that right? And x times 5x is positive 5x squared, isn't it? Is equal to, so it's going to bring this along, this negative 22x's, we haven't used it yet, 22x's. Now this is really going to help you. I'm begging you to pay attention because you know a lot of stuff, and people say, well, how the hell would I know where to go from there, what to do from there? You don't. You got to start looking for patterns. So look at this thing right here. I noticed this. I was like, you know what? This thing is quadratic now, isn't it? Because of that x squared, right? The highest exponential value of a variable is a squared. That means we have a quadratic, and we know that we solve those by saying that ax squared plus bx plus c is equal to 0, right? So that's what we're going to do. We're going to add positive 22x's to both sides. And now we have 0. This 0, you guys, is this one, because I recognize this is a quadratic, and that's how we set them up to be solved, is equal to 5x squared plus 30x's, isn't it? Now, something interesting is going to happen here. And what's interesting that's going to happen here is that we're going to factor out here, aren't we? So we're going to factor out, look, this one has x squared. This one has a single value of x. What's the greatest common factor of 5 and 30? So the greatest common factor of 5 and 30 is 5, isn't it? The greatest common factor of x squared and x is just a single x, isn't it? And then we have to multiply to put it all back together. So 5x times x is 5x squared, and 5x times positive 6, right? So set that equal to 0. Now here's what gets interesting. When we factor this, when we solve this, we get x is equal to 0, right? Because 5 times 0 is 0, so that would be an answer. And when is x plus 6 equal to 0? When x is negative 6, right? X equals negative 6. But when we go back and plug this in into the original equation, we find out that this is an erroneous answer. It's actually called an erroneous solution. So there's our erroneous solution. Okay. Okay. So that's technique 1. I think I'm going to save this video and do another one so I don't kill you with this whole thing.